This is the second video for sections D to H of the Trig module. In this video we are looking at application problems. Now with application problems, the following procedure can assist you in presenting a solution. Always draw a diagram labelled with your values if you aren't provided one, and put where your unknown variable is. List any assumptions used to set up the diagram. So with what we're doing in this trig, you're going to have a right angle somewhere. Okay, so where is it? Define the variable being used in the solution. Write out the trigonometric rule you're going to have to use. Substitute in the values. Solve for the unknown variable. And answer in a sentence with appropriate units. If you have a worded question, you should always answer with the worded answer. Now the key with these is definitely that diagram. The diagram forms a part of your solution and will be marked. So let's look at the first example. A 1.2 metre ladder leans against a wall, making an angle of 35 degrees with the ground. How far up the wall does the ladder rest? Well, let's start with our diagram. We have the ground and we have our wall. And the ladder is leaning against the wall. Now our first assumption is that the wall makes a right angle with the ground. And you would list this assumption. I'm not going to do that because it just wastes your time listening to me. Now, it's a 1.2 metre ladder, so this is 1.2 metres, and it makes an angle of 35 degrees with the ground. Well, this is our ground here, so ground, and this is the ladder. So the angle the ladder makes with the ground is this one here, so that's 35 degrees. Question is, how far up the wall does the ladder rest? So our unknown variable is, what is that there, that x. So now we have to figure out what we've got. If we label our diagram, opposite the right angle is our hypotenuse, opposite the angle is our opposite, and the other side is our adjacent. We're given the hypotenuse and we want to find our opposite. So using SOHCAHTOA, O and H is for sine. So we write out our ratio, sine theta equals opposite over hypotenuse, fill in our information, sine of 35 equals the opposite, which is x, over hypotenuse, which is 1.2. We need to solve for x, so we're going to times both sides by 1.2 to get that x on its own. So that means x equals 1.2 times sine 35. Go to your calculator. Make sure your calculator is in degrees. Sometimes they get switched into radians and you get weird answers. So 1.2 times sine of 35 gives approximately 0.69. And we're talking about meters. So therefore the ladder reaches approximately 0.69 metres up the wall. Okay? Next, the radius of a right circular cone is 15 centimetres and its semi-vertical angle is 52 degrees, as shown in the diagram below. Find the slant height of the cone, S. Now the great thing here is everything's been given to you, so if you weren't too sure about what a right circular cone is or what the semi-vertical angle is, it doesn't matter because it's in the diagram. Now we're trying to find this S here, so let's label our diagram. Opposite our angle is opposite our right angle is hypotenuse, and our other side is A. What are we given? Well, we have 15 metres, which is our opposite, and we want our slant, which is hypotenuse. So again, looking at SOHCAHTOA, O and H is for sine. So sine theta equals opposite over hypotenuse, sine 52 equals 15 over S. Now, here we need to get that S up the top. Essentially what we're doing is just swapping them. So S equals 15 over sine of 52. Be careful when using S's and 5s that they don't end up looking the same. So 15 divided by sine of 52 gives me, again it's approximate, 19.04, and we're in centimetres. Note correction here that 15 metres should have been 15 centimetres. Okay, so we would finish with a therefore statement. Therefore, the slant height is approximately 19.04 centimetres. Next, an 18 metre guy wire supporting a pole forms an angle of 29 degrees with the ground. How far is a guy wire pegged from the base of the pole? Okay, think about it. We have the ground and we have a pole. Okay, an 18 metre guy wire supporting a pole, that's the wire that comes out from the pole to the ground, forms an angle of 29 degrees with the ground. Okay, how far is a guy wire pegged from the base of the pole? Well, the peg would be here, so from the base of the pole, that's my X there. Our assumption is that the pole is at 90 degrees of the ground, so at right angles with the ground. And the other thing that it tells us is that it's an 18 metre long guy wire, so 18 metres is there. Label our diagram, opposite our angles, opposite our right angle is hypotenuse, and the other side is adjacent. We have our hypotenuse and we want to find our adjacent. So using SOHCAHTOA, which one has A and H in it? It's cos. So cos theta equals adjacent over hypotenuse. Cos 29 equals x over 18. We need to get x on its own, so we need to get rid of this 18. X is being divided by 18, so we times both sides by 18. Do the opposite. X equals 18 cos of 29. Plug that into your calculator and you get approximately 15.74, and we're in metres. Again, finish with a therefore statement. Therefore, the guy wire is pegged approximately 15.74 metres from the pole. Next, a tourist slides 24 metres down a new straight water slide. The slide begins 15 metres above the ground. What is the angle the slide makes with the ladder? So let's think of our picture. We're going to have a ladder. Now, to be able to do this question, we're going to have to assume that ladder is at right angles with the ground. Then we have our ground, and then we have our slide. So assumptions: ladder is straight and vertical, ground is even and horizontal, which means that our ladder makes a right angle with the ground. And you should list those assumptions. The slide is 24 metres long. The slide begins 15 metres above the ground. What is the angle the slide makes with the ladder? This is our slide here. This is our ladder, so the angle it makes with the ladder is there. So that's my unknown. Label, opposite the angle, opposite the right angle is hypotenuse, and our other is adjacent. We're given our hypotenuse, we're given our adjacent, what we want is the angle. So A and H, SOHCAHTOA, A and H is cos. So cos theta is adjacent over hypotenuse. Cos theta, adjacent was 15, hypotenuse was 24. You have to make sure they're in the same units as well. In this case they're both metres, so that's fine. We need theta, so we're going to find inverse cos of 15 over 24. Don't reduce this to a decimal. Leave it as 15 over 24. So when you go to your calculator, go inverse cos bracket 15 divided by 24 bracket. Otherwise you're rounding twice, which means your answer is even less accurate. And that's approximately 51.32 degrees. And again, you would finish with a therefore statement. Therefore, the slide makes an angle of approximately 51.32 degrees with the ladder. Next, the Great Pyramid of Cheops in Egypt has a square base 230 metres on each slide. The faces of the pyramid make an angle of 51 degrees 50 minutes with the horizontal. What is the shortest distance you would have to climb up a face to reach the top? Well, if you're not great with geometry, luckily there's a picture here, so you don't have to try and interpret everything. It does explain that the right angle triangle, that this side here splits the square in half, so it's 115 metres, so half 230. The one thing you may not have seen yet is 51 degrees 50 minutes, and if you look on your calculator you should see a little button that looks like this. That's how you enter the degrees and minutes. Angles are actually in degrees, minutes and seconds, and if you go into the next level mathematics, you will encounter degrees, minutes and seconds more. So let's label. What are we trying to find? What is the shortest distance you have to climb up the face to reach the top? Well, that would be that X there. So opposite the angle, opposite the right angle is hypotenuse, and my other is adjacent. So I'm given the adjacent side, I want the hypotenuse. So A and H is cos. So cos theta equals adjacent over hypotenuse. Cos 51 degrees 50 minutes equals 115 over X. Swap these over, so X equals 115 cos 51 degrees 50 minutes. To enter that in your calculator, 115 times cos. Now when you enter your degrees and minutes, you just go 51, hit that degrees, minutes, seconds button, and then 50, and then hit that button again, and then press enter. And when I did that, I realised that I made a mistake here. If we're swapping these over, it's 115 over cos 51 degrees 50 minutes. Sorry about that. So again, 115, this time divided by, much better, cos, again, 51, hit the degrees, minutes, second button, 50, hit the degrees, minutes, second button, press enter, and you should get 186.10 approximately. Now, if you get a negative answer, the reason for that is when you've put this in the calculator, you've forgotten to put brackets around the divide. So it's 115 divided by open bracket cos 51 degrees 50 minutes close bracket. Okay, finish with a therefore statement. Therefore, you would have to climb approximately 160.10 metres. Always remember your units. Okay, next, a bug is looking up at an angle of 30 degrees to a bird that is sitting on a brick fence. Now you could get really creative with pictures, or brick fence, ground, my bug is here, and up here is my bird. Get the idea. Okay, so he's looking up at an angle of 30 degrees to the bird, and the brick fence is 1.8 metres high. We're going to assume that the brick fence is at right angles with the ground. We're going to assume our ground is flat. And what we need to find is how far the bug is from the fence. So X. Label our triangle. What do we have? I want adjacent. I'm given opposite. So O and A is tan. So tan theta is opposite over adjacent. Tan 30 equals 1.8 over X. Swap these over. So X equals 1.8 divided by tan of 30. Plug that into your calculator, and you get approximately 3.12, and it's in metres. So again, therefore statement, the bug is approximately 3.12 metres from the fence. Now this is quite a long video because I'm doing all the application problems at one time. Remember, you can pause and take a break. We've already been going for almost 15 minutes. A ladder is placed against the wall. The foot of the ladder is 4.2 metres from the base of the wall, and the ladder reaches 8 metres up the wall. What angle does the base of the ladder make with the horizontal ground? Okay, so let's draw a picture. Ground, wall, ladder. We're going to assume our wall is at right angles with the ground and the ground is flat, not that it looks like from my picture. The foot of the ladder is 4.2 metres from the base of the wall, so that's 4.2 metres here. The ladder reaches 8 metres up the wall, so that must be that one there. What angle does the base of the ladder make with the horizontal ground? Well, here's my ground, here's my ladder, so we're looking for that angle in there. Label my diagram. Opposite my angle is opposite, opposite my right angle is hypotenuse, and the other one is adjacent. So I've been given adjacent and opposite. So O and A, which is from SOHCAHTOA, tan. So tan theta is opposite over adjacent. Tan theta is 8 over 4.2. So theta equals inverse tan of 8 over 4.2. It's going to be approximate. Remember to use your brackets, so inverse tan bracket 8 divided by 4.2, close your bracket, and you get approximately 62.30. And we're doing an angle, so it's in degrees. Finish with a therefore statement. Therefore, the ladder makes an angle of approximately 62.3 degrees with the ground. Next, from point A on the bank of a river, a surveyor made a sighting of a tree on the opposite bank. The surveyor then walked 60 metres along the bank at right angles to the sighting to point B. From point B, the tree was at an angle of 32 degrees. Find the width of the river. Okay, let's start by drawing in our two banks and our rivers in the middle. Okay, opposite point A is a tree. So here's my tree. So opposite the tree is A. Right? From there, the surveyor walked to point B. So I've finished my triangle, and we're going to assume that this is our right angle here. So let's go through the information again. From point A on the bank of a river, a surveyor made a sighting of a tree on the opposite bank. The surveyor then walked 60 metres, so this is 60 metres, along the bank at right angles to the sighting to point B. So we're assuming that this river is parallel, basically. From point B, the tree was an angle of 32 degrees. So that's 32 degrees here. Find the width of the river, which is X. Okay, so let's label. Opposite the right angles, hypotenuse, opposite the angles, opposite, and then we have adjacent. So we want opposite, and we're given adjacent, so O and A is tan. So tan theta is opposite over adjacent. Tan 32 is X over 60. So times both sides by 60. You get X is 60 times tan 32. Plug that into your calculator and you get approximately 37.49, and we're in metres. Finish with a therefore statement. Therefore, the river is approximately 37.49 metres wide. Next, a 5 metre long ladder leans against a building. Now we're into our mix section here, Trig H2. So a 5 metre ladder leans against a building. You find in Trig there's a lot of ladders leaning against buildings. So we're going to assume this is my right angle, ground's flat. It's a 5 metre long ladder. If the ladder makes an angle of 40 degrees with the horizontal, well, the horizontal is the ground, so that's 40 degrees here. How high up the wall does the ladder reach? So that's my X. Label my triangle. So we've got hypotenuse, we've got opposite the angle, and the other is A. So we're given hypotenuse and we want opposite. So O and H is sine. So sine theta is opposite over hypotenuse. Sine 40 is X over 5 times both sides by 5. X equals 5 sine 40. Hopefully you're finding that these are pretty straightforward. It's really just coming down to labelling your triangle. If you label your triangle correctly, the rest isn't that difficult. It's kind of like the same thing over and over again. So finish with your therefore statement. Therefore, the ladder reaches approximately 3.2 metres up the wall, 3.21 metres up the wall. Next, again, another ladder. Don't know about you, but I'm kind of over the ladders. Person writing this textbook must love these questions. So there's my diagram. 2 metre long ladder. We're going to assume this is a right angle, with its top reaching a height of 1.8 metres. So that's 1.8 metres there. What angle does a ladder make with a wall? Well, ladder and wall, so we want that angle in there. Labelling, opposite the angle, opposite the hypotenuse, then we have adjacent. So we have H, we have adjacent, and we want our angle. So A and H is cos. So cos theta is A over H. Cos theta is 1.8 over 2. Theta is going to be inverse cos 1.8 over 2. Plug into your calculator. Again, remember your bracket. So inverse cos bracket 1.8 divided by 2. And you get 25.84, and it's degrees. Again, therefore, the ladder makes an angle of approximately 25.84 degrees with the wall. Next, a wire attached to the top of a 15 metre high flagpole. Okay, so let's draw a picture. I haven't even read the rest of the question, just drawing my picture. Okay, so a wire attached to the top of a 15 metre high flagpole, so the flagpole is 15 metre high, makes an angle of 68 degrees of the horizontal. So that's 68 degrees. We're going to assume that that's a right angle. How far from the flagpole is a wire attached to the ground? So that's my X there, because the wire is attached to the ground here. Labelling, opposite my angle, so opposite my hypotenuse. Sorry, opposite my right angle is my hypotenuse. I keep doing that. And my other is adjacent. So I've got O. I want A. So O and A is tan. So tan theta is opposite over adjacent. Tan, plug in, 68 is opposite, is 15 over adjacent, which is X. Swap these over. X equals 15 over tan of 68. Plug into your calculator. 15 divided by tan of 68 is approximately 6.06, and we're in metres. So finish with a therefore statement. Therefore, the wire is approximately 6.06 metres from the base of the flagpole. I don't know about you, but I'm exhausted. We're up to the last question, so I'm very happy about that. 2 roof trusses form an isosceles triangle. So, an isosceles triangle has 2 sides equal. Okay, if you've done geometry, you would have remembered that. With a base width of 9 metres. So that means this length here is 9 metres. If the roof truss is 5 metres long, so 5 metres, 5 metres, find the angle between the 2 trusses, is theta there. So this is a little bit difficult if you haven't done the geometry module, but most people who do trig also do the geometry module. So if I cut my triangle in half, because it's isosceles, I am literally cutting it in half. So this is 4.5 metres. Here is a right angle, and this angle here is theta over 2. It's literally half of what I had. So if I label, opposite my angle is opposite, opposite my right angle is hypotenuse, and then I've got adjacent. So hypotenuse and opposite is sine. So sine theta is opposite over hypotenuse, that's my ratio. In this case it's sine of theta over 2 equals opposite 4.5 over hypotenuse of 5. So theta over 2 is going to be inverse sine of 4.5 over 5. Plug that into your calculator, again remember brackets, and you get approximately 64.16. So theta is going to be approximately 64.16 times 2. Now even though I've written 64.16, I'm actually using the answer in my calculator. So I already have the full unrounded answer on my calculator, so I'm just going to go times 2. So I haven't approximated twice. And you get 128.32 degrees. So again, finish with a therefore statement. Therefore, the angle between the two trusses is approximately 128.32 degrees. Okay, so you've already done the first part of all the exercises, which were the knowledge questions. Now you have to go back and do all the application questions. Hopefully you're realising that once you understand how to label a triangle, the application questions really just come down to the drawing the diagram. Okay, good luck.